Hello. Yeah. Let me discuss about the pin diagram of 8051 microcontroller. See here, it is a 40 pin IC. The pin number 20 and 40 are for the power supply. That is a 5-volt VCC. I mean 5-volt DC supply you have to give to work this 8051 IC. Now let us see the pins P1.0 to P1.7. It is a port P1 8-bit. Port P1 8-bit. Then we have reset. Reset pin number 9 is a reset to reset the microcontroller. Then we have here port 3.0 to port 3.7, port 3. So this port 3 not only as an input output, it is also have some special functions like port 3.0 can be used as a to receive the bit in serial form, and also port 3.1 can be send the data in serial form TXT. Then port 3.2 can be used as a external interrupt input. Then similarly port 3.3 also external interrupt signal can be applied for this pin. Then port 3.4 for if you are going to use as a timer as a counter, in that case the input will be given from external. Whenever any object occur, this pin is going to give the input as a clock pulse will be generated, that will be applied through this pin. So that counter is going to count number of inputs. Similarly for counter 1, this input. Then we have write and read signal. To read or write the data into memory, we are going to use these two signals. For read operation, for reading, we are going to use read signals will be sent. For writing the data into memory, write signal will be sent. Then these two XTAL1 and XTAL2 will be connected to the externally crystal, so that this internal is a oscillator circuit. Crystal will be connected externally. From these two pins will be given as an input here, and inside is going to generate the clock. Then pin number here 21 to 28, port 2.0 to port 2.7. These pins can be used as a address as well as a IO pins. A8 to A15, another function. Then we have program store enable. If we are going to connect any EEPROM, so this pin is going to connect to that memory, ROM memory. So it will be given as a program store enable signal from this. Then yearly address latch enable, as you know that here that address and data will be combined to separate. We are going to use this signal, address latch enable. And external access, if you are going to connect any external memory, we are going to connect this external access pin. Then we have port 0.0 to port 0.7, this 8 pins. And these 8 IO pins can be used as a address data lines, as it is mentioned AD0 to AD7. So now look at here, this is the actual the microcontroller, the physical boards. Practically you can going to use like this board. It consists of this 8051 microcontroller, and it is having ports as mentioned here, port 0, port 1, port 2, port 3. These ports are going to use to connect any IO devices. And this another one, this black strip, it is a push-pull registers. Inside is a registers are there. Okay, that is called push-pull registers. Then we have this power supply section. The actually power is applied here, 12 volt DC or AC. Okay. So, so it is 9 to 15 volt or 8 to 12 volt. It is AC, 9 to 15 volt DC. In this range can be applied here. So this voltage can be converted into 5 volt because this IC required 5 volt supply. So in turn is converted to 5 volt. So if it is AC, it is converted by this bridge rectifier. Bridge rectifier is going to convert if it is AC DC, and in turn this regulator is going to convert to the 12 volt to 5 volt. There is a filter will be there before the regulator. There is a filter that is AC components will be removed with this filter. Okay, then finally connected to the regulator to get the constant voltage. Then we have these two pins for transmit and receive pin for connecting externally in serial form, or we can use this here through this cable. RS-232 cable can be used. So to make compatible this RS-232 cable with this IC compatibility, to make compatible, we are going to use MAX232, this IC. It is called level shifter. Then we have, this is for RTC, okay, real-time clock. You can connect if required, you can connect this. Then we have, these are the features available on this board. This is LCD. LCD will be on board. Then we have LEDs. LED will be connected. So there is a reset pin to whenever if you want to start execution, first you have to press the reset button. You start executing from the beginning. So this is in brief about the components of this board. Is a physically available this board. You can make use of it. And here, see the difference. Here only the minimum requirement. I have not shown any LCD, any RTC. Here only the minimum required. Power section will be there for power. Then reset pin is there. Then we have for connecting to the desktop system. As you know that we are going to develop the program in desktop. We'll write program in assembly or in C and convert into machine code. Then machine code is going to download to the memory of the controller. Then here the crystal, here also it is there. A crystal oscillator. Crystal will be connected externally. So it's going to generate the clock. This is a minimum components required. So this board is also, you can use it. And externally you can connect any LCD, any LEDs, or any keypad, any other sensors, motors. You can connect any actuators like motors. You can connect. So now the pins, as I shown you in the previous slide, similarly the pins are like port 1, port 0, port 2, port 3. So here how we are going to connect pin number 9, the reset. There is a reset button. How it is circuit will be there. It is shown in detail. And about the crystal oscillator, I was going to generate the clock. This is a minimum circuit connections. The internally IO pins, how it is connected. There is a D flip-flop will be there. Then we have buffer, the tri-state buffer, then internal pull-up register, and there is a MOSFET. So you can perform read or store or write. This is actually hardware structure internally how it will be there. That is D latch for storing this pin and tri-state buffer and transistor. So this is about how we are going to write one to this pin. Okay. See here you can write the one pin to it will be stored in this and is available here. Okay. And this Q bar becomes 0 and this transistor will be off state. Then VCC will be connected here. We are going to get as a 1 as the output. And similarly, writing 0, here it become Q bar become 1, and this become on this transistor. So this transistor become on, it is connected to the ground, we get output as 0. Then for reading, this for writing we have seen, for reading high, stored as 1 here, 1 is available here. So this output Q bar will be 0, this is disabled, and this here VCC is connected, 1 you are going to get here. Okay, you can read as a 1 from here. So is the VCC connected, 1 you can read. The read pin will be enabled. So you can read the 1 into the controller. Similarly, you can read low. So if it is stored as, you can read as low from the pin. So for that, you can read from the external pin as low. See here, you can read as a low at the input pin. Now let us see how we are going to use these pins for connecting any external devices. For example, here we are taken as a 7-segment display. Here we are taken as a 7-segment display as an example. So it's a common cathode, is nothing but all its negative terminal is connected common cathode. Whenever you send high, that particular segment become low. The corresponding LED become on. So the minimum connections for reset, and this is a clock. So here the port one is connected to this 7-segment display. So this is how we are going to interface 7-segment display by using these pins. So here the purpose is to understand how pins can be used. See here, port 3.0, port 3.1 can be connected to the MAX232, intern is connected to the RS232 cable, and intern is connected to the desktop system. So we can develop here program and then download to the memory of the controller. This is the process. Now let us see how we can connect these pins to the LCD. See LCD, this is the LCD of 2 lines, 5 cross 7 dots, and 8 data lines, and 3 control lines, RS, read write enable, register select, read write enable. And here is connected the VCC and ground for supply. Here also connected the supply. See how we are going to connect. You can connect keypad also for the input pins and also LCD. So here the purpose of this diagram is to understand how pins can be connected to the external device. Physically, you can connect like this also by using the breadboard.